Hi, good afternoon, good evening. I wanted to talk about 5 concepts that just about every chemistry student, or a lot of chemistry students and biochemistry students especially, may get confused about. They're often misunderstood. So these are like 5 terms, 5 concepts that are very important to understand, especially in biochemistry, that are often just not understood or not understood very well. Now, the first one of these is pH, right? Now, what is pH? I think a lot of students may think pH just refers to how acidic or basic something is, right? Maybe a solution, something like that. And pH actually goes a lot further than that. Yes, it's related to acidity and basicity. The pH scale was developed by Søren Sørensen back in the early 20th century. And so he actually worked at Carlsbad Laboratories. That's associated with Carlsbad Brewery. And what's interesting about that brewery, why are we interested in pH? Well, beer is actually slightly acidic, and Søren Sørensen was interested in making better beer. So the whole pH scale we kind of owe to the fermentation industry, interestingly enough, right? No, the pH scale is 0 to 14. And so anything with a low pH, less than 7, because 7 is right in the middle. Anything from 0 to 7 is acidic. Anything from 7 to 14 is generally basic, right? Now, what exactly is pH? Technically, pH is that little lowercase p before the H. That refers to the negative log of the hydrogen ion concentration, right? And so it actually, technically pH is actually a measure of the concentration of hydrogen ions in a solution on a logarithmic scale, right? And so obviously acids are also proton donors, bases are proton acceptors. So if you have something with a lot of protons in it, you've got a fairly low pH, because the lower the pH, the higher the hydrogen ion concentration. If you have something with not a lot of protons in it, you've got a high pH, and so it's kind of inversely proportional right there, like that. Now, if you're looking at the strength of an acid or a base, that's not pH at all. That's actually the Ka, the acid dissociation constant. And so that acid dissociation constant, the higher that is, the stronger the acid. So hexafluoroantimonic acid, I think that's in many organic chemistry textbooks, that has a very low, I think is off the charts in terms of a pKa, which is the negative log of the Ka, has a very high Ka. I think that's also off the charts as well, right? So that's like what they call super acid, right? And so the Ka and the pKa basically govern what is the strongest acid or the strongest base. Now there's also a pKb and a Kb. Kb is the base dissociation constant. So that governs high Kb as a stronger base, like ammonia or sodium hydroxide. A low pKb is going to be a stronger acid or a weaker base, right? Because everything on that scale, you could have something that both acts as an acid and a base, right? Like water. Water has a pH of 7. It's right in the middle. And it also has multiple pKa's and pKb's, because water can serve as both an acid and a base. It can accept a proton, making it a base. It can donate a proton, making it an acid. So the hydronium ion being the acid form of water. So that's pH. Now you can relate pH and pKa. Those two things are commonly related. That's related by the Henderson-Hasselbalch equation. And the Henderson-Hasselbalch equation is very important. That states that pH is equal to pKa plus the log of the base over the acid. And so then we can actually determine the pH of something given its pKa and given the amount of base and acid that we have, right? The second most commonly understood thing is the term organic, right? Now, I've probably scared a lot of students just by saying that word, because you're thinking, oh my God, organic chemistry. I hate that. Okay. Yeah, that may incite nightmares in some people. It's really not that bad. Organic in chemistry is just the chemistry of carbon compounds, which includes, that's important to biochemistry because our proteins, our fatty acids, all that, our DNA, it's basically carbon skeletons and carbon chains, right? So I think organic is referring to the chemistry of carbon. Now, the misunderstanding kind of comes to when you visit the grocery store and you go especially to the produce section and you see all this food that's labeled as organic produce. And you're thinking, what does that mean? It means that it's generally all natural and it doesn't contain any man-made pesticides or any man-made chemicals. Because when we're in the grocery store, chemicals are bad, right? We don't want to eat chemicals, and we want to eat all natural stuff. Well, the truth is everything that your body is made out of, proteins, fatty acids, vitamins, minerals, carbohydrates, those are all chemicals. All of the food that you consume is a chemical, right? All the minerals are chemicals. So your body is made of chemicals, and if you don't eat chemicals, you're going to die. So you want to eat chemicals, you just want to eat the right ones. So that's kind of why the term organic can be somewhat misleading. So that kind of ranks number 2 on my list here, right? Now, number 3, one of the most important concepts that is often misunderstood is the term catalyst. And so what is a catalyst, right? Now, often the misunderstanding here might be that a catalyst provides energy or it becomes part of a reaction or of the products, right? So that's not exactly the case. The catalyst actually does not contribute directly to the product itself, right? The catalyst just lowers the activation energy. So you've got the activation energy, it's up here. It's a big hill to climb. We're going to lower that activation energy so we don't have to climb as high of a hill, right? And so one great example of this is the decomposition of hydrogen peroxide. Now, hydrogen peroxide is commonly found in many first aid kits. It's a strong oxidant, so it kind of oxidizes. If you have a cut or a bruise, it's going to oxidize anything in there and kill any of the bacteria, right? Now, this is why you want to check your first aid kit, because that first aid kit, you put the hydrogen peroxide in there. Hydrogen peroxide, H2O2, is going to slowly decompose over time to water and oxygen. And so if you've got a really old first aid kit that hasn't been used in several decades, that hydrogen peroxide is probably no good, right? Because it's already been decomposed. Now we can speed that reaction up. If we speed that reaction up, we're actually going to make, we're going to do that reaction in a matter of seconds, right? So speeding that up, that requires a catalyst. We can use potassium iodide for that. And potassium iodide doesn't enter into the reaction. It's not part of the reactant. It's not part of the products. It just helps to complex with the hydrogen peroxide to help break that bond between the two oxygens and give us our water and oxygen, right? So that speeds things up. If you want to see this, there's a lot of YouTube videos out there of elephant's toothpaste. They actually add a little bit of soap to capture the oxygen, and they add a little bit of water. It's also a highly exothermic reaction. Great reaction to check out, and it's very highly entertaining as well too. So that's really good. All right, now the fourth concept that is often misunderstood. Now, calories calories confuse a lot of people, right? And so you see this a lot in diet plans and weight plans and all that stuff. Because everyone's saying, oh my God, calories, I'm going to put on a lot of calories. And it's thought to measure like weight gain. I'm adding calories to my diet and I'm going to gain weight. Or it's a measure of fat content in food. Well, what is a calorie? A calorie is really just a unit of energy, right? Now, the official SI unit of energy is the joule, but calories are also used to measure energy. And technically, 4.184 joules is equal to 1 calorie, right? Now, when I say 1 calorie, I'm talking about an SI unit calorie. In the United States, we're going to refer to calorie with a capital C instead of a lowercase c, right? And that capital C calorie, that's called a food calorie, and that's actually a kilocalorie, which is 1,000 SI unit calories, right? So 4.184 joules is equal to 1 SI unit calorie, and that, if we multiply that 1,000 times, that's 1 kilocalorie, right? So that also confuses a lot of students as well, too. And that calorie, so we use the joule as the SI unit because we actually relate energy to mass, right? That's the official definition. And the joule is actually related to Boltzmann's constant. And that's the more accurate measurement of energy. Now, the calorie has its beginnings because obviously we live on a water planet, and everything we do is focused on water. And in biochemistry, 65% of the human body is water. So it makes sense that we're going to define a unit of energy based on water. And so a calorie, again, that calorie, and so if we're talking about, again, 1 kilocalorie, actually, it's just a unit of energy, and that's the energy. This is a food calorie, so 1,000 SI unit calories. This is the energy that's needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. That's the definition of that calorie, right? Now, if we're talking about weight gain, where does that come into play? Well, you need to consume approximately 3,000 calories of energy per day, right? And I think you want to consume less because if you're trying to lose weight, you want to consume less calories than you use because you're both consuming calories in your diet and you're expending calories through metabolism and exercise. So if you consume more calories than you expend, then you're going to gain weight, right? And that weight is actually going to be stored as fat. But if you consume less calories than you expend, then you're going to start burning fat because that's going to require energy, and that's going to go to weight loss. So calories, that makes number 4 on my list of the top 5 misunderstood terms in biochemistry. And so what's number 5? That's the last one. And again, these, I'm not sure if I'd put these in any particular order. This may not be the most important one. By the way, if you find all this interesting, before I go on to the last one, go ahead and hit that like button on your channel. Or go to subscribe to the channel as well if you like all this content. Hit that subscribe button and click the little bell icon. You'll be notified of changes and updates and that sort of thing. And feel free to comment if you find this information all interesting and want to see some of the other content as well. So the last one, protein. Protein is often kind of misunderstood because a lot of people kind of think that proteins are really just nutrients, right? And that's true. Proteins are macronutrients. That's 20% of our diet. And, 30% of our diet is fatty acid and 50% of the diet is carbohydrates. So most of our energy, 80% of the energy, comes from carbs and fats. But proteins, they can be consumed for energy, but the reason you're going to consume protein is not so much as an energy source, but actually protein is composed of amino acids. And when you consume that protein, you're going to break down the protein for those amino acids, and then your body is going to use those to build its own amino acids and its own enzymes. So that's going to increase your metabolism and increase your ability to obtain energy from carbohydrates and fats, right? So everything you do is protein. And so if you're building muscle mass, right, you need more muscle mass, you need more mass of your body, you need to consume protein. So you want to consume all that protein, all those meats or feta, tofu, I should say. Those are all good sources of protein. You want to consume all that protein so that you can break down those amino acids in that protein. You can use those amino acids for your own good, right? The process of breaking down proteins in the diet is called catabolism. Building that up, taking those amino acids and making bigger proteins, that's called anabolism, right? Those are the two components of metabolism overall. So you need to consume protein. You can break down protein for energy through the citric acid cycle, but that's not the primary source of energy. You're going to use those amino acids for other things. So I hope you found this useful. And those are the 5 major things that are part of, that are probably common, mostly misunderstood, right? Until next time, hope you learned something.